Hi, welcome to the latest installment of the Audio Engineering Society Standards Committee webinar series. These are held every other month and showcase technology from activity in one of the AES standards working groups. I'm Rich Cabot, Secretary of the AES Standards Committee, with a short introduction to the AES Standards Committee. AES Standards is the meeting place for audio professionals, whether you're in product design, manufacturing, system design, or a content provider, broadcast facility. Typically, you have use of AES standards. The things that you use, things you do are covered by one or more AES standards. And AES standards allow these products to interoperate reliably, predictably, and provide the fundamentals for the technologies that are used every day in the audio community. AES standards are respected in the audio community, and we hope that you will get involved in one or more of the standards committees to help move progress forward. The activities of the AES standards committees are divided into several broad groups, one on digital audio, one on preservation and restoration of audio recordings, one on acoustics, and one on interconnections. And the committees and working groups involved meet periodically to develop new materials, new standards, new information documents. And if you'd like to get involved, please contact me at standards@aes.org or visit the website aes.org/standards. And today we have a presentation from Jeff Berryman on Aes70, and I will let Jeff take it from here.
All right, let's get my screen shared here. Right thing.
Okay, you're up.
Here we go. There I am. All right. Rich, am I visible and is my screen visible?
Your screen is visible.
Okay. I don't know where I am, but people don't need to see my face if they can't see it. Okay, today we're going to talk about the Aes70 object model and how to use it. I'll talk about what the object model is in relation to Aes70 as a whole. We're going to go fairly fast because I have a lot to present. There's, as you can see from the table of contents over here, in this presentation, there are a lot of other topics that I won't even cover today, but this presentation will become available, and it's intended to be sort of conveniently navigable. All of these things are clickable. You can go to the respective sections and so forth, so that you can, if you want to read more afterwards, you can. So the background, a quick background on Aes70. Aes70's mission is to provide full function device control and monitoring for applications that have these parameters: professional applications, multi-vendor systems, mission critical applications, small and large networks, secure or insecure networks, multi-controller systems, controllerless systems, audio devices, maybe video devices in the future, other equipment, all sizes of devices, from tiny microprocessor driven devices to big ones, dynamically reconfigurable devices, and products with proprietary features, over all kinds of networks, and hopefully supporting sharing and reuse of designs and an orderly evolution of the standard. So it's a full industrial strength control protocol. It was what it is, what it's always designed to be, what it was from the outset. Okay, what's the Aes70 object model, subject of today's presentation? It's an object-oriented framework for media device network control interfaces. What that means is that there's a big repertoire of control classes. A control class is a template for a control function API, and these control classes represent all of your friendly audio devices, gain controls and equalizers and dynamics and stuff like that. There are also control classes for connection management, so controlling connection and so forth of media streams to the device and so forth. Excuse me. And there's a set of related data type definitions that support these control class definitions. A standardized device model, which means what's inside your basic device and how to add your function to it. And it is documented in the AES70 standard named number 2, the AES70-2 member of the standards family. I will describe the whole standards family later on, but I haven't put that description at the beginning because it'll be easier to understand once we go through some of the rest of this stuff. What's not in the object model? It's not, the object model itself is not a control protocol definition. It does not define the exact format of what goes along the wire, but the AES70 standards family does have such a definition in AES70-3, but that actual description of what goes along the wire is out of scope of today's presentation. AES70 object model is not a media transport protocol definition. That's what AES67 is. So AES70 will work with all different kinds of media transport standards, but it doesn't define one itself. It's not a programming model for devices. AES70 is not going to tell you how to design the software inside your device. They give you some hints, that you have, but you may or may not choose to follow those hints. As long as your device speaks correctly along the wire, what's inboard of the RJ45 doesn't matter, or is out of scope of AES70. And nor, finally, AES70 is not a user interface model for controllers. It is not going to tell you how you make how your screens should look, that the users will see when they're running controllers controlling network devices. The name OCA floats around hand in hand with AES70 all the time, and so I just have this slide explaining the difference. OCA stands for the Open Control Architecture, which is the original technology underlying the AES70 standards family. This technology dates back to the early 1990s to a previous AES standard called AES24 and has gone through a number of evolutions and so on. But more in about 2009, it was, or no, 10, I think it was renamed to be OCA, the Open Control Architecture. There's a history. This is sort of like the difference between MADI and AES10. AES10 is the standard, MADI is the name of the technology, if you're familiar with that stuff. Today, the word OCA has been expanded a little bit to denote not only the original technology, but the whole ecosystem surrounding AES70. There's reference to implementation, documentation, tutorials, development to all kinds of stuff that is associated with AES70. Who does what? The AES publishes the formal specifications of AES70 as standards in the family, AES70-1, -2, and -3, and more coming, as I will describe in the family later on. The OCA Alliance Trade Association, which dates back to about 2011, is the originator of the technology, and it works hand in hand with the AES to develop and maintain the entire OCA ecosystem. There'll be links and stuff later on in the presentation you can look at. So to get right into it, what is a control class? Remember, the object model is made up of control classes. What's a control class? A control class is an AES, is a definition of a network control API for a particular kind of device functions, switch, gain control, level monitor, and so on. So each control class defines a little set of network functions that can be used to control the respective function inside the device. AES70 control classes are defined for both control and monitoring functions. So there's gain controls, but there's also level monitor, the BU meters, and so on. Each AES70 class has a name beginning with OCA. I'll give you an example. OCA switch will be an example later. And control classes are instantiated into control objects. So if you had a device with two switch functions in it, there would be two OCA switch objects. They would both be based on the same OCA switch class or template, but they would be distinct objects themselves to allow the controller to distinguish between the two functions. AES70 objects define the control APIs, but they do not define the internal implementation. So an AES70 object, I should have written actually classes here. So that's a wrong word, but both are true. But, just because we have an OCA switch class with a few function does not say how you're going to program that function or design the hardware inside the device. And finally, the device's AES70 control API, the overall application programming interface of the device, the face that the device puts out to the network saying, here's how you control me over the network, is just the union of all the individual ones. So if you have a device with a couple of switches and some gain controls and so on and so forth, you add together those little interface definitions, and that the sum total of those is the overall control interface for the device. There are lots of proprietary, well, there are not lots of it, there are strong proprietary features in OCA, so that if you, in AES70, so if you have to, if you're a manufacturer implementing a device that has some special kind of processing or something, you want to define a special function and control it in ways that are consistent with AES70 standards. You can define proprietary extensions that you can use. These proprietary, and that you can define a proprietary class. The proprietary class can be instantiated into proprietary objects. These objects can be hidden if necessary. And I put this in boldface because there's to address a kind of common fear. So here we go. AES70's virtual control panel objects do not reveal proprietary elements any more than physical control panel knobs do. We call AES70 the overall device API, the virtual control panel. It's like a control panel that's accessed by controllers instead of humans. But there's nothing inherent in AES70 that requires manufacturers to disclose anything secret about their device. It's just whatever the device publishes on the network is up to the manufacturer. Okay, so what is in a control class programming interface? Control class API is a classic object-oriented interface. It's got properties, methods, and events, and there are ways of accessing these over the wire. Property is a variable that defines the state of an object. A method is a function that changes a property value or does something else. And an event is a predefined condition that can arise in the object and cause notifications to be returned to controllers. You know, for example, a level monitoring object will generate an event, or can generate an event whenever the level changes. There are also ways of making sure that too many events don't get generated, you know, when you don't want them. But in principle, an event can be generated whenever something changes, or whenever it changes by a certain amount, and that's how controllers follow the life of the device. It's also how multiple controllers are supported, you know, so that if you have two controllers on your network, and one of the controllers changes something, the other controller, if it's set up right, will receive an event saying, hey, my gain just went up 10 dB. Data type classes are a programming construct that you'll also find in AES70-2. They have no APIs, they're just data formats that are exchanged by controllers and control objects. And so they have properties, but they don't have methods or events. And data type might be a simple element, such as a dB, which is defined to be a value in decibels. And actually, if you look under the hood of OCA-DB, it's a 32-bit floating point number. Or data types can also be more complex structures. And here's how we represent time in a way that's compatible with IEEE 1588. So this particular data type, which is called OCA time PTP, has three elements to it. It has a little flag saying whether it's positive or negative. It has a value of seconds and a value of nanoseconds. That's just an example of a structure data type. So these won't come up a lot for us today, but you'll see them. They're scattered all over the AES70-2 definition. By the way, the Q&A, I'm watching the Q&A box over on the right. I don't promise to, so if you enter a question, please feel free. I don't promise to answer it right then. I'll take a look at them as they come up and see if they fit now, or in the moment or later. I'm hoping my question and answer capability is working. There's a little strange indication on it that suggests it may not be. But if, I hope I'm wrong, but if by any chance you ask a question and it doesn't get answered, please feel free just to email me afterwards, or I will be joining the Discord, the AES Discord server. I don't belong to it yet, but I will be joining after this presentation, and you can ask me there. But you know, the easiest way to get me is just send me some email anytime. My email's a couple places in this presentation. It'll be down at the end, but it's ja.berryman@us.bosch.com to be fast about it. Anyway, to continue, here's an example of a class. OCA switch is a class that is used to control a device parameter with a fixed number of predefined states. It might be device on off, high, medium, low, left, center, right, etc. And the controller can select the desired state by specifying its index. So this will control a multi-position switch or a single position, multi-pole switch or a single pole switch. Notice that there is no distinction at this level between a number of poles in a switch. So a single pole and a double pole, a triple pole, you know, a switch will all have the same control interface, because when you change a position in a multi-pole switch, you change all the positions, however many, or all the poles, however many poles there are. You know, there's one knob on a 5-pole switch or a 10-pole switch. So this is the knob. So there's an integer. So these are properties. These up here are properties of the class. There's a property called position. Whoops, excuse me. There's a property called position. There's a property called position names. There's a property called position enable. The position itself is the current position. The names are the names of the switch position. Remember, this is an n position switch. So if you want to define a 3-position switch, you can be high, medium, and low, or left, center, right, you can. And then these flags are flags to turn the positions on and off. So you might have some positions that in the current state of the device aren't reachable, and you might want to disable those to prevent controllers from trying to enable it to set them. And then these down here are methods: get and set, get and set, get and set. And so these change the values of these properties. Each one of these methods ultimately corresponds to a protocol command that can be sent along the wire. So the controller can send a get position to retrieve the current position. The answer the device sends back to the controller will be the value of this property position. Here it is there. To change the position, the controller invokes set position. To discover the position, the controller invokes get position. To configure the switch's position names, the controller invokes set position names. And all these methods are invoked by control protocol commands. Moving on. Okay, control objects. So remember, OCA switch was a class of things. So you can build switch objects out of this class. You can build in your device. You can build a 2-position switch and a 3-position switch and a 5-position switch, all using the same class. But each of those will be a separate object, an instance, as we call it, of the controlled class. Every object is an instance of an Aes70 controlled class. You identify every object by its number. Every object has an object number that's unique within the device. It's a 32-bit unsigned integer. The manufacturer may freely choose the values of these ONOs, except that they can't use the low numbers. We save those for special purposes. Every object has a property, and properties have values. Objects have get and set methods for retrieving and changing property values. We've seen that up above. Some objects have action-oriented methods that don't specifically relate to each property, like a method, you might have a method called start, for example, for some process inside the device. Protocol command messages call methods return status values via protocol result messages. Features 2, events. Object have events, I should say, may have events that cause notifications to be emitted. Notification is a message sent from the device back to the subscriber, and a subscriber is a controller that has told the device it wants to be informed about something. I want to be informed when the audio level changes. I want to be informed when something changes to gain. Um, there are different kinds of events, but as I've kind of hinted here, the property changed one is the most important one. There are other kinds of events that don't relate specifically to properties, like trying to think of good examples. Well, trust me, there are other ones, but property change is the most important one. Defined for all Aes70 objects, every object has the capability to inform a subscribing controller of when things have changed. And this is, as I pointed out before, this is the notable use of this is to allow multiple controllers to stay in sync without polling. You know, a goal of Aes70 is to make it never necessary to be constantly asking a device about something, be it an audio level or is your temperature okay, or has your gain changed? None of that stuff. Aes70 has methods, features that make that unnecessary, because polling doesn't scale on big networks, and Aes70 scales up to big networks. Okay, what kind of control classes are there? Well, there's categories, first of all. There are worker classes. There are actuators, which are classes that control audio processing, sensors, classes that monitor the device. And there are these blocks and matrices that collect objects into groups. I'll say a little bit more about some of those later, particularly blocks. And then there's a set of objects called agents that affect the flow of timing and control, but don't directly change signal processing. There's a set of objects called control object called networks, that are connection management classes that allow controllers to change media connections. Like if it's an Aes67 device or something, they can change what goes to what. We will not be looking at those in detail in this presentation. That'll be a future presentation. And then there are managers that are overall housekeeping classes. There's a device manager that lets you find out the device serial number and stuff like that. But there's more detail. Here's a list of actuators. It's in the current version of Aes70, which is Aes70 2018. And you can see all the names begin with OCA, and there they all are. And you know, so you start to see there are these ones which are sort of audio specific, audio friendly names. Then there are these ones that are just sort of programmatic types, so that if you end up with something you want to control in your device that isn't in this list, you can still control it by just defining a number somewhere in your device that you're going to control, and controlling it. You know, if the device has I don't know, panel illumination brightness control or something, you know, that isn't reflected in any of these classes. You can just define yourself a floating point 32 number or something, or an 8-bit integer, whatever you want, that controls the panel illumination brightness. So those are all the actuators. And again, these can be extended by proprietary classes. You know, the proprietary mechanism allows you, if you want your own special version of OCA gain that's like a stepped gain controller or something, you can make one for your device. Sensors, the counterpart of actuators. There's a smaller list, but there's a level sensor, and there's a related version, a child of a level sensor called audio level sensor that contains standard meter laws like PPU and PPM and VU laws that does the average signal averaging stuff. Time interval sensor, frequency sensor, temperature sensor, and identification sensor, which is what you use if you have a button on your device that you're supposed to push to tell the controller, here I am. You push it. The controller can watch the sensor to figure out which device got its button pushed. And then there's the counterpart, these elementary types of sensors. Other kinds of classes: blocks, matrices, and networks. A block is a container that allows the collecting of workers, agents, and networks into organized groups, and I'll give examples of that below because that's important. And a block factory is an advanced concept that is used by devices like reconfigurable DSP devices that allow you to create signal processing objects on the fly. I will not be dealing with that in detail in this presentation. A matrix is a generalization of an audio matrix. You can use matrix to create switch matrices or gain matrices, or even way more complicated matrices. That's described in this presentation, but I won't be going there either too much today. And then these network classes, which again, I will not be talking about much today. One of the reasons I don't want to talk much about networks today is there's an upcoming release of Aes70 that'll be probably out in the middle of the summer, that in which the network stuff is all quite a lot modified. And so I don't want to necessarily be talking about the current mechanism too much. Agents, these are things that don't deal with signals. There's a thing called a grouper, which is think of it as the traditional audio example is a VCA master. It's a thing that can control multiple set points at once. A ramper, which is a thing that allows the device to do crossfades and things like that inside itself. You can say, change the gain from this value to that value starting at this time and take 5 seconds to do it. These observers are things that are used to manage the generation of events, things like audio level. This is what you use these kind of things if you say, I want a meter level reading every 50 milliseconds. Power supply controls power supplies in a device where you need to control power supplies, like battery powered devices and stuff. Media clock and time source are two timing related things that are for sample clocking, and time sources for time reference, which is mostly used for media transport, but can be also used separately. And then there's a physical position object. It's a position and orientation object that's used for object-oriented audio work with the various surround sound tools that are out there now. It supports physical position supports various different standards that are used to locate virtual objects to locate objects in a space. They could be virtual audio objects, or they could be the physical position of a device in a rack if you want to use it for that. So the physical position is real or virtual position, it just depends on the implementation, but the coordinate systems are pretty much the same. Then these managers, which are overhead objects, most of these are optional. And the device you don't really need to implement that you can see here required. These are only conditional. These two are only conditionally required. So there are only really two required managers. This device manager that manages the global device identification and status, and the subscription manager, which is how controllers subscribe to different events that, watch properties that they want to see changed and so forth. So these I'm not going to go into in any depth. They'll come up in specific contexts, probably in the future, maybe future presentation. Excuse me. Here's how they all relate together. There's a basic class in the class tree, and all classes inherit from this class OCA root. Workers inherit are one. You'll see these familiar categories are one particular class that has different subclasses. I don't go into this too much. It doesn't matter too much for this presentation, but you can see that actuators are children of workers. Sensors are children of workers, and the black vector maze are also children of workers. Then there's the network classes down here, the agent classes over here, and the managers over here. So all these classes OCA root defines a set of common functions that all of these classes have. OCA worker defines another set of common functions that all of these classes have. Agent defines some common functions that all those classes have, etc. So there's the inheritance tree. This is nothing you normally need to care about. The only time inheritance really becomes important in OCA is if you want to create a proprietary class. You got to decide what it's going to inherit from. So now going on, I want to talk a little bit about blocks. If you have consider this, that OCA sees a device as a bag of objects. So from an AS, I should say Aes70, from an Aes70 object model point of view, a device, a bag of objects, and every object is uniquely identified by its object number. But you really want to have some kind of organization. So if you have a 64 channel mixer, for example, that might have in it, and every channel might have 25 gain control functions or something. That's 25 times 64 objects that you've got in your device, not to mention all the groups and all the masters and all the other ancillary functions. Just the basic channels of the console are a huge number of objects, and every channel has the same kind of objects in it. So you want to kind of be able to express that, and you do it with a block. A block collects objects into meaningful groupings, keeps track of how signals flow among the objects. In dynamic devices, it supports construction and destruction of objects. Dynamic meaning things. What I mean by dynamic object is a dynamic device is something where your controller can create and destroy signal processing elements, one of these flexible DSP type things. That's a dynamic device or dynamically configurable device. And blocks contain a reuse mechanism so that once you've defined a block, you can use it in multiple instances. So for example, if you have a big mixing console, you can define a block specification that says, all right, I have preamp gain control object, and I have some parametric equalizer objects and some dynamics objects and some mute switches and a master fader and so on. And all these are all my objects of a particular channel. And then I'm going to make all those into a block definition. And then later, I'm just going to replicate that block definition 63 more times to create the definition of my 64 channel mixer. So you don't have to redefine everything every time. So that's the kind of the idea of blocks. In a smaller example, just even a stereophonic device with two channels, you could define a block that was a channel and then just replicate it for the second channel. Block, every object except manager object belongs to exactly one block. So an object can't belong to multiple blocks. It'd be too confusing. Same as you can't have a gain control that is on one channel strip and on the next channel strip at the same time. It makes no sense. Blocks do not provide mastering and submastering functions. So just because you put objects in a block, if you put 10 gain controls into a block, it doesn't give you a master gain control for all of those. That's a separate function in OCA. So Aes70's mastering and submastering functions kind of resemble VCA mastering more than traditional physical mastering. The aggregation relationships of objects. If you have a single submaster gain control here, that's a sort of a pattern that's overlaid on top of the block structure. So these, 10 gain controls that belong to 5 different blocks, but you can have one control aggregator that controls all of them or some of them. They're independent of each other. There's a section in this presentation that I will not have time to talk about today that talks about it. It's called control aggregation. You can look at it if you look offline later. Continue with blocks in general. Blocks may be nested to any depth. So for example, you might find it in your channel, in your microphone channel mixer control channel strip. You might find it useful to have one block that defines a standard multiband parametric equalizer, and you might use that block in a whole bunch of different products, and so you can configure that block. You take that block and plunk it down inside the channel strip block, and then replicate that whole thing. So there's a block inside a block, and that can be true to any depth. A block itself is the format of a block, and the way your controller talks to blocks and figures out what's inside a block and this and that and the other thing. That's all defined by the OCA block class. And as I've kind of implied, using blocks help make device control APIs cleaner and easier to use. A block is officially defined as a worker, and a worker is something that has a signal path. I think I haven't talked about signal paths yet. I'm a little bit out of order, but you'll see that in a minute. So these are different. But every block has one of these object numbers that I described before, just like the gain control and the switch has its unique number that identifies it inside the device. As well, a block has an alphanumeric role name property, so you can name these things channel 1, channel 2, channel 3. Every block has an optional global type property, and this is a property that says it's kind of like it's almost like a skew. It says so if you're a mixing channel company, you have all these mixer products and you want to define a standard channel, you can give it a global type identifier, which is it's a complex, the format of a global type identifier is complicated in order to make sure that no two manufacturers ever have the same global type identifier. So you define your global type identifiers, and then it allows you to keep track. If you want to reuse the same mixing strip definition in 5 different products, you can. They'll all have the same global type property, and it simplifies management and reuse of your intellectual property. Every block has enumeration and search capabilities that allow controllers to figure out everything that's inside the block and in internested blocks, and to find objects inside the block based on, if you want to search for, I want to find something that's, the compressor gain reduction level meter or something like that. You can search for it if you know its role name. Every device contains exactly a minimum of one block. It's called the root block, and everything except managers belong to it. If you want, and when you make a device that has more than one block, all those blocks are inside the root block. So the root block always contains everything, and all the objects either belong directly to the root block or to things that are inside the root block. And we're in time. All right, signal flow. This is where I got a little bit out of order today. One of the things that blocks also allows you to keep track of is, optionally, is the signal flow inside the device. And so the device can these little blue lines are all signal paths. And so you can the object model, the object model allows you to model a port. These circles are called ports. It's a place where a signal arrives or leaves. You can model, in this case, model a signal entering the block and going to the first thing in the block, whatever it is, gain control, equalizer, mute switch, whatever, and then coming out of that one, going to the next one, and so forth. You can have these kind of direct links if you want to other things in other blocks. That's not a very good idea, but you can do it. And blocks can talk to blocks, and you can in general build up a whole representation. If you want the controller to be able to see and or change the internal signal path of the block, you would include specifications in your block specification that define these blue lines. So Aes70 allows you to define these blue lines. There are various details about it, but the basic idea is that Aes70 allows you to define this picture with signal flowing around from here to there. Not all devices will find it necessary to define those blue lines, but they're there. And certainly if you have a dynamic device where the controller can create and destroy these yellow things, then you probably do need to keep track of the signal path, because otherwise you don't know what they do. Here's a block example. I don't have time to go through this in detail. It's here. You can look at it, but here's a block that this is an 8-channel thing. There's 8 channels of something. These red things are the role names, so you can look and inside each one of these channels there are all these things, all these elements, and including another block called the EQ block. And inside the EQ block are all these various filters, and these different names are different classes of filters that you can define in Aes70. So that's this picture. I invite you to look at it kind of offline and see all of the sort of summarizes everything I've been kind of talking about. Identifiers. Just to summarize, I've kind of talked around this. Here are key Aes70 identifiers. These are identifiers that controllers have to know for some reason. You have to know when you're building your device, and you have to know, and controllers have to know them when they're controlling the device. First of all, a class ID. Every class has a class ID. The format is complex, and I'm not going to explain it, but most of the time it looks like a number with multiple decimal points. I believe, for example, if my memory serves me correctly, that the class ID of OCA switch is maybe 1.1.4.2 or something like that. But every class has a unique class ID. It's unique within the standard. If you create your own proprietary class, it has to have an ID, a class ID that's all its own as well. So every class is identified that way. And also every class has a version number that allows you to introduce subsequent versions of things. Inside a class, inside a class, you'll recall I mentioned that classes have properties, methods, and events, and each one of those elements has an element ID also. And there's a format for that that I won't discuss right now. It's a little simpler than a class ID. Now, object number. Every object, not every class, a class doesn't have an object number because a class isn't anything, it's just a template until it's instantiated into an object. But once the class is turned into an object, you have to give that object a number. So every object has a 32-bit object number. And also an object may have a text role name that identifies its role in the containing block. So you can have some object number is some weird number, but the role name could be preamp gain. The rules for these identifiers, the class ID unique in the Aes70 standard, and and every object constructed from a given class will have the same class ID. So if you have 5 switches, they will all have this 1.1.4.2 or whatever it is ID. The same version number, same. If you create an object from a particular, when you create an object from a particular class, it will have a version number that will be propagated into the object as well. Element IDs also the same. That when you create a switch, your switch object will have its properties, methods, and events identified by the very same element ID that the ID values that the class defines. You can't change those when you instantiate something. Object number, different for every object. Values may be freely chosen, so it must be unique for each object in device. Freely chosen. I left out the except for 0 to 4095. You can't. Anyway, there you go. And role name is optional if used, and if you use it, it should have a unique value for each object in a block. So don't make a block full of 10 gain controls and call them all gain. Call them gain 1, gain 2, gain 3, something like that. Every control object in an Aes70 device contains these identifiers. These identifiers, of course, are also important in the protocol, but if you actually look at the signal going along the wire, if a controller is trying to call a particular method to have a certain effect, it will contain, the controller will need to specify the object number, which is the object to be affected, and the element ID, which is the ID of the method within that object that is to be invoked. So these two things in particular are key for any protocol that is defined for Aes70. At the moment, there's just one. I'll mention it in a minute. Okay, now so we have all these objects and all these classes and stuff. What does a device actually look like? Well, here's what a device looks like, but don't worry, a lot of this is optional. What's really in a device has to have a device manager. It has to have a subscription manager. If it implements the secure option of Aes70, which uses the TLS protocol, it also has to have a security manager to help manage the keys. All these other things are optional. I won't bother with them right now. The more interesting part is what's inside the root block. It has to have a root block. Root block always has an object ID of 100. And oh, by the way, and these managers have fixed object IDs too. The ID of the object ID of the device manager is 1. And I can't remember what the subscription manager is. It might not be 2. They're historical. Anyway, they're fixed and they're documented. So, but in the root block, this is where you put all your objects that are actually going to affect real application control functions. So there's workers, which include actuators and sensors. Pardon me. Agents, which these control function mediating things, and networks. And so you can pick and choose and put whatever you want in all of these things. And depending on what you put, sometimes it requires you to add other managers here too. That's a detail that we'll ignore right now. We're going to now here we go to a design example. I've got about 8 more slides, I think, and there were 8 or 9 more slides that matter. Let's design ourselves an 8-channel mic preamp. We have 8 analog inputs. They're switchable with line to mic level. Each input has phantom power, high pass filter, and polarity switch. And there's an Aes67 output. All right, that's our hypothetical product. Start. All right, we create a basic device. What has to be in this device? All right, here's a device, big box on the outside. It needs to have a device manager, a subscription manager, and a root block. So that's our starting point of our design. To this, we add clock and time source objects, and these network objects, which as I've said, will be described later. Just right now, trust that there is inside here a connection management mechanism. This will allow Aes67 connections to be made to the output of this product. And that we're going to start to add audio functions. So we add a channel block. So there's channel 1, empty block. It's nested inside the root block. And then what we're going to put in channel 1, we're going to put this stuff. There's a switch for the phantom power, a gain control, switch for the high pass filter, a polarity switch, a microphone load impedance switch, excuse me, another switch is determine whether the input is line level or mic level, and then this sensor that's going to report the audio level going through that channel. So there's a simplified channel. Okay, I didn't put any equalizers in there and stuff like that. I don't want to complicate the picture. This is just a mic preamplifier. I did just the high pass filter is the only thing that's in there. So there we got a channel. So now what do we do? Now we replicate this channel, make them all the same. Now I say replicate, but in doing so, we cannot use the same object numbers for this. If let's say we start at 496, or let's say we start at, I don't know, 10,000. So this OCA switch might be 10,000, gain 10,001. Another switch to 10,000, 10,000, 10,004 was this 10,001, 2, 3, 4, 5, 6. So that's 10,006. Now, so the same objects are going to be inside this second channel, but they can't have the same object numbers, so they have to start at whatever you want, 20,000 maybe. Again, you can choose these numbers. The maximum value is 4 billion. Is a 32-bit unsigned integer. So that's kind of it. We have now designed the control interface for our mic preamp, and what happens? Well, what's the resulting API? Each object publishes its own API, and the complete control API is a union of all its objects' APIs. Each class's definition implies the API definition. No further specification work is required. So at this point, we have defined the Aes70 control specification for this device. And by a suitable reference to the protocol documentation and whatnot, which is out of scope of this presentation, a controller, knowing only the contents of this device, can control it. Now, there are two ways for controllers to find out the contents of this device. One way is if they're a custom controller, the contents can just be programmed indirectly. So the fact that this is object number 10,000 could just be known by the controller, hardwired into the controller. Or a more general purpose controller could, in fact, knowing a little bit of basic Aes70, query this channel block saying, okay, what do you have inside? And the controller would come back and say, well, I have an OCA switch and it's object number 10,000 and it has this name associated with it, 48V, and I have this OCA gain object and its object number is 10,001, and I have associated with it this role name of gain and so forth. And the controller could discover, without previous knowledge, what's inside. Now, that said, that doesn't say anything about how those objects are going to be presented to a user. Aes70 doesn't say that, but it does allow controllers to discover what's inside devices that they've never met before. So that's it. That's the sort of design process that I wanted to kind of take you through to target when you start to think about designing OCA control and so forth. This is how you go about it. Now, as I said before, you could also, if you're a manufacturer, you could say, well, I've got I've got an 8-channel product and a 16-channel product and a 2-channel product and so forth. And they all use the same channel design. And so I could give this a global type identifier, which is some long string, you know, and then I could use it in all my different products. And when a controller discovers, oh, okay, this is a block with global tentative identifier, blah, 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 I go, I know what's inside that block. I know how to control it. I know what user interface to present for it and so forth. So that's how global type identification could speed product development when you have multiple products involved. That's about the object model. Now I'm going to give you a little more background on things. First of all, what is the Aes70 standards family? Well, it's about to get bigger, and I wanted to give you just a little idea of that. These are the AES standards that are either existing and about to be updated or new, or about to be released. So Aes70-1 is the Aes70 framework. It's a text document, defines the basic Aes70 mechanisms. It's about 60 pages. Aes72 is the class structure. That's the object model. That's mostly what we've been talking about today. It's a text and UML document that defines the control and monitoring repertoire. UML is a design language. It stands for Universal Modeling Language, and it's a way of formally representing many things, including class structures, object models such as this one. If you're not familiar with it, there's some pointers to explanations that I'll get to in a minute. And then the document 3, Aes70-3, is what actually goes along the wire. It's a binary protocol. It's a document that defines a protocol called OCP1. It's a protocol that for using Aes70 over IP networks, uses a TCP protocol or optionally the UDP protocol. It can have secure and insecure implementations. It can also run over the WebSockets protocol that's used by web browsers to do TCP function, to have TCP functionality. So this is now Aes70-3 is not the only protocol that can be used to access Aes70 devices. It's the only one defined at the moment. There's a new one coming out. It's Aes70-4. This is new. It's a JSON protocol, and it will define a protocol called OCP.2, a protocol that also works over IP networks, but it may be, we've had some demand for it from programmers who would rather work in JSON than work with binary constructs running along a wire. There is, for those of you familiar with these kind of tools, there is a free Wireshark plugin that decodes OCP.1 that's available from download from, I'll get to that. But if you're not comfortable with that and you want to use JSON, you can. Now, of course, a device that speaks Aes70-3's OCP.1 and a device that speaks Aes70-4's OCP.2, those two devices are not directly compatible. So you kind of have to decide what you're going to use. You could have a device that spoke both, but you probably wouldn't normally do that. So this gives a choice of protocols, and it does kind of divide the world into two classes of Aes70 interoperability, but we're responding to popular demand for this JSON protocol. In addition to these 4 core protocols, there are 2 what are called adaptations. An adaptation is a document that describes how to use Aes70 with another protocol. These 2 adaptations are about how to use Aes70 with media transport protocols. There's one that, that describes how to use Aes70 with Aes67 media transport. And I should actually have updated this. It also describes how to use Aes70 with SMPTE ST2110-30 media transport, which is a subset of Aes70. Well, it's a almost subset of Aes70. It uses Aes70 in a particular way, adds some constraints and stuff. So this -21 document will define both. Its title actually includes both media transport standards. That's an advanced state of completion right now. Aes70-22 is a a protocol that's being developed by a group of manufacturers, most of them loudspeaker manufacturers, who use an AVB media transport protocol called Milan. And this will 22 will describe how to use Aes70 to manage Milan stream transport connections. And those manufacturers who are developing that will presumably be using it. So all of these versions, the current versions of everything is 2018. Everything will be published in mid-2022. So all of these documents on this page will be published as 2022 versions, probably in the summer. That's the family for now. Just looking at a quick feature. So what all can you really do? This is more for reference. I'm not going to go through all this. We've seen various examples of this, but this kind of lists just what you can do with Aes70 apart from the mechanisms. And I'm not even really sure why I put this slide here, but I did. Now, Aes70 resources sites. Here's a good site to get this free public technical resources and so forth. OCAalliance.github.io. It's called the Aes70 tech site, free public technical resources for Aes70 developers. Excuse me. HTTP OCAalliance.com is the usual sort of trade association website. It has promotional material and links to tutorials and this and that and the other thing about OCA. There's a new tool out that hasn't, it'll eventually be linked in this tech site, but hasn't yet, called Aes70 Explorer. There's a very nicely finished, one of the OCA Alliance members has produced a very nicely finished free to try controller that runs in a web browser and can be used to control the Aes70 device. You can do drag and drop. You can drag and drop control interface definition. So you hook it onto a network with Aes70 devices, finds all the Aes70 devices, puts up a toolbar saying, here's everything I found. You click on the device you found, opens up, and here are all the things inside the device. And you can drag stuff out of that expanded toolbar item onto the main canvas on the main screen, and the right kind of controls will appear: sliders, meters, knobs, switches, etc., to allow you to control the device. It's not intended as a commercial development tool. The company that produces it wants to be a free resource to developers, and also as an attractive advertisement for the fact that they have commercially available licensable tools for developing controllers with a similarly nice look and feel. It has a very nice look and feel, the Aes70 Explorer. How to get Aes70 standard documents. This page on the tech site is a good place to start. It also contains some explanation of the UML, the Universal Modeling Language that I mentioned before, and that language is the access to the tools of that language is also, I should add, explained within the Aes70 standard texts themselves. So there are a couple of ways of learning UML if you don't, and UML tools if you don't have them. So here's the address of the OCA Alliance. There's me. There's my email and my phone number. And then the Alliance business contact in case your company wants to join the Alliance. So the Alliance doesn't exist to gain members. It exists to increase adoption of Aes70, but there are certain membership advantages if you want to have a look at it. And then the AES channels, as Rich has already said in his introduction, if you want to get involved in the AES standards side of this, you contact him. Participation in AES standards does not cost anything, is open to, and it's an individual by individual membership in AES, not a company by company membership. So that's about it. The other topics, these are the topics that, now I'm gonna go back. These are the topics that I'm not covering today. And good thing, because we only got 2 minutes left. I don't see any questions in the chat, but as I say that, maybe because my chat is, or my Q&A pane, but that may be because my Q&A pane is broken. So if you do have them, please get in touch with me, and I hope this is giving you some kind of a high altitude flyby of how you go about thinking about Aes70 and how you go about developing devices, or at least envisioning devices that use it. So that's about it. I guess we're stopping. I was worried about getting finished early. I guess I got finished 1 minute earlier or something, or finished late, but I guess I got finished on time.
There's a couple questions in the Q&A.
That's interesting. My Q&A is broken because I'm not seeing them. Okay.
The first one says, you say get and set. How is Aes70 like Snmp?
Well, Aes70 is a more, I mean, it has some similarities to Snmp because they're both control protocols. Snmp has a more basic set of types. It has a different kind of structuring where you create an information block for each device, and you operate on that information block. There are gets and sets in a lot of protocols. It's just a word for whether I'm sending you information or whether I'm receiving information. But the idea of Aes70 was to create something that was sort of more audio oriented and was perhaps a little more rigorous in the way that it was extended in proprietary ways, that was a little more protocol independent, so that you didn't have to, so that using the Aes70 object model didn't require you to use a particular Aes70 protocol. You know, also had a little bit more of a structured event mechanism that maybe made multiple controller support more easy, and you know, and opened and had in general features that were more compatible for dynamically modifiable devices, where controllers could modify them on the fly. There were a bunch of differences between of those sorts of differences between Aes70 and Snmp. Snmp is kind of a low-level protocol that allows you to do everything, but not necessarily in a way that's easily evolved or expanded in proprietary directions, and not necessarily in a way that facilitates easy interoperability between multi-vendor devices. You end up with controllers having to know a lot about every specific device to control it, and when versions change and stuff, you have a management problem. So it's a you know, Snmp was designed to control, was designed for network management. NM stands for network management, as you probably know, and network management issues in general tend to be a little more straightforward than control of audio processing, which has a wide range of styles, and you know, has things like mastering and submastering. You know, how you're going to do that in Snmp, except without a whole lot of just everything being custom every time. So we tried to subsume some of the more advanced audio functions in a more audio specific protocol, and left the network management to Snmp. I hope that answers your question.
The other question we got is somebody wanting a copy of the presentation slides. We normally do post those after the presentation is done.
Yeah. And normally we put it, there's also a video of this presentation that's going to end up somewhere, right, Rich?
Yes.
Yeah. So the slides are certainly available. I will, you know, produce.
There's a page on the AES Standards website where we list slides from previous presentations.
Hey, you know, I should, next time I do one of these presentations, I should get a link to that page from you, Rich, and I'll put it in my presentation. Yeah. On the bye-bye page or something, you know, or probably on this front page.
But if you search around the standards portion of the AES website,
you know offhand the URL, the name of that page, Rich?
I can find it quickly enough, I think.
Pardon me, because we could just put it in the Q&A, put it in the Q&A, or put it somewhere right now, right? And, I can't edit this page, but if we have a second, it might be helpful just to have it.
Yeah, I will put it in the chat as soon as I Find it.
Thank you. I'm going to copy it as soon as you do.
Okay, any other questions?
There are also slides, I would assume, I haven't looked, but there are also slides from my previous presentation that last November, that was a more basic introduction to AES70, should also be in that same page, I presume.
Yeah. Okay, from the standards main page down at the bottom, it says webinar slides, but let me put.
Let's see if I do a little Zoom trickery here, I should, oh, there it is. We have it, okay. AES.org/standards/webinars. Let me see if I can just do this. I'm going to change what I'm sharing to my development screen. There we go. And then put it in here. I'll just put it here for now. Like that, maybe. Like that. And then anybody who sees it and shares it with their friends can also get a copy or something like that.
Okay, do we have any other questions? Any other?
Thank you.
No more open questions? Okay.
Thanks.
Thank you again, Jeff. And we'll get these slides up probably within a day.
Okay, great. Are the videos in that same, linked in that same?
They're not. They're on the AES, I believe, on the AES YouTube page.
Okay.
Where the videos live.
I'll probably update this slide before I give it to you for I'll just right after this presentation, I'll find where they are, where the videos are going to end up, and put that link here as well.
Okay.
Great. Well, thanks everybody.
Okay. Thank you.
Thanks.